Hi, I'm Caleb Horst with CellScale Biomaterials Testing. I'm joined today by Professor Leandra Baptista from Federal University de Rio de Janeiro. Thanks for joining us, Professor. I wonder if you could start by just telling us a little bit more about your research.
Our research teams work in scaffold-free 3D culture systems. The interesting things about spheroids is that when spheroids is created from adult stem cell sources, these stem cells recapitulated morphogenetic events. It's possible to create in laboratory a sort of tissues like bone, cartilage, and adipose tissue.
So you're using the microsquisher to study your microtissues, and I know there's a lot of factors in terms of cell type and cell behavior. Can you tell us a bit more about why mechanical forces and mechanical properties are important for your research?
When you think about bone and the cartilage, you think about tissues that in our daily they are submitted to mechanical forces and mechanical wear, okay? So if you are generating bone and the cartilage in laboratory, you need to generate strong tissues, okay?
I see. Can you tell us more specifically what data the microsquisher can give you and how it's relevant to the research that you're doing?
When you use microsqueeze, it's possible to measure these strains, these forces, and microscale. It's very important for us. And you can put the spheroids between the two compression plates and do something like that. So when I do this, we measure this return of our tissue constructs. And especially when you think about the cartilage tissue is a tissue that when you walk, they have to resist to this. So we can prove using microsqueezes that our cartilage built in laboratory is capable of to resist for this, okay? It's also possible to get our other measurements like surface tensions of spheroids. It's possible to obtain the Young modulus, and the Young modulus is very important because there is some reports in scientific literature telling about the optimal Young's modulus of tissue constructs. So there is no main result, but a combination of parameters and forces that it's possible to measure using the microsqueezer.
It's a really interesting application. I'm sure you've done many different types of tests. Can you tell us, has there been anything surprising that you've learned using the microsquisher to test these microtissues that you work with?
Working with this analysis, we realize that maybe this analysis could be a good reference for us. We realize that the mechanical strength it's one of the first parameters that the spheroids loses after they become to lose their viability, okay?
It's a really interesting application that you're working with. Where are things going next? What type of things do you have planned for your research?
Our next step is about the in vivo, okay? But for in vivo protocols, there are two main approaches. So we can deliver the spheroids directly to injury site when you have a small defect of bone or cartilage. But if you have a critical defect in these tissues, So it's necessary to obtain a more complex tissue in microscale in vitro. So for this, we can use the spheroids as building blocks, but because the spheroids have the capacity to fuse to each other, so it's possible to, for different approaches like bioprint, it's possible to fuse these spheroids, but realize some interesting things is that when you have spheroids with a high mechanical strength, we need to get this when you generate cartilage or bone, but for the other side you have some difficult to fuse these spheroids to each other. So now we are working on in some emissions obtained from microsqueeze, such as surface tensions, for example. So we expected to get some standard of surface tensions that works with as some kind of limitation. So okay, you can get this bone with this X surface tension. So using these spheroids, it's still possible to fuse it with each other or not. So the microsqueeze for us will work is like a kind of standard for that.
Well, it's really great research you're doing. I want to thank you for joining us today, Professor Baptista. And thank you all for watching this video. If you have any questions about this research or about CellScale's products, please contact us. We'd be happy to talk with you. Thanks.